Right, this is the review for parallelograms for our final. So the first two slides just have the theorems listed there, or the properties. So parallelograms are defined as having two pairs of opposite sides that are parallel. That's why they're parallelograms. And then we have the four additional properties. Two pairs of opposite sides are congruent. Opposite angles are going to be congruent. Consecutive angles are supplementary. They add up to 180. And then the diagonals bisect each other. They split each other in half. So this piece and that piece are the same, and that piece and that piece are the same. Okay, slide 2 here just kind of has the reverse theorem. So if the opposite sides are congruent, then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. If opposite angles are congruent, then it's a parallelogram. If consecutive angles are supplementary, then it's a parallelogram. We also had the additional property here, though, or the additional theorem. If one pair of opposite sides was congruent and parallel, then the quadrilateral was a parallelogram. You don't really have to worry about that one. That one's not going to be on the final. Okay. So it's just our definition, two pairs of opposite sides parallel, and then you have the four properties, and then the inverse of those as well. All right, so first up, opposite sides are congruent. So problem can't get easier. AB is 13.9. Since it's a parallelogram, opposite sides are congruent, so that's also going to be 13.9. And then BC will be 16.4. Okay, and we're still using the same property here. Opposite sides of a parallelogram are congruent. So 4x, Jm is going to be congruent to KL, so 4x is going to equal 3x plus 5. Okay, and then you can solve for x and plug it back in. You're looking for KL, so solve for x, substitute it back in. And then the other equation you're going to have is y plus 3 equals 2y minus 1. You can solve this equation for y as well, substitute it back in, and you're looking for jk. Okay, so that one you're just solving your equations. Opposite sides, or you're setting opposite sides equal to each other, solving the equations, substituting the answers back in to find the lengths of jk and kl. All right, number 5, we're going to use the two angles properties. So opposite angles are congruent, consecutive angles are supplementary. Since this is a parallelogram, we know that W, angle W, the measure of angle W is 112. And then we can do consecutive angles are supplementary, so they add up to 180. They're same side interior angles. Since the lines are parallel, we know that they have to be supplementary. So 180 minus 112 is 68. Then opposite angles are congruent, so that's 68 as well. All right, number 4, same thing, except we have expressions instead of numbers. So you can do opposite angles if you want. X equals 2y, and then 4y equals 5x minus 180. Okay, this is a little harder though because you're going to have to do substitution or elimination. You'd probably want to do substitution. You'd substitute in 2y here. So you would do 4y equals 5 times 2y minus 180. Right, and then you can solve for y, and then substitute that back in to find x. But probably the easier way to do this one would be to just use the consecutive angles. Okay, so we know x plus 5x minus 180 is going to equal 180, right? The consecutive angles add up to 180. We also know 2y plus 4y then you can solve for x. Substitute it back in, solve for y, substitute it back in to find the measure of angle A and the measure of angle D. And we'll leave you to do the rest of that. All right, our next property or last property here for parallelograms is that the diagonals bisect each other. So since this is a parallelogram, we know the diagonals split each other in half. So if HG is 14, we know EF, or I'm sorry, if HG is 14, we know EH is also going to be 14. And then if we know this whole piece here is 20, right, we know each individual piece is going to be half of that. So each of those pieces will be 10. So EG is the whole thing here. So 14 plus 14, that should give you a total of 28. And then DH, simply 10. Okay, the diagonals bisect each other. They split each other in half into two equal pieces. Right, and then next one will be the same thing except with expressions. Okay, so diagonals bisect each other. So again, we know x plus 6 is going to equal 10. And we know that this piece here will be equal to this piece. So just to simply solve, you subtract 6 from both sides. We're going to get x equals 4. Substitute in 4 for x there. So 2 times 4 is going to give you 8. And if this piece is 8, that piece is also 8. So then your entire thing would be 8 plus 8, 16. All right, number 9. Is there enough information to prove that this quadrilateral is a parallelogram? Yes. Our theorem was if opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram, right? This was opposite sides are congruent. That one should be a yes. Okay, is there enough information here? So we have 12 and 11. No, there's not going to be enough information here. We only have two sides. Again, if we look at our properties or our theorems, right, we need opposite sides to be congruent. We don't have opposite sides that are congruent. We would need opposite angles that are congruent. We don't have anything on the angles. Consecutive angles are supplementary. We don't have anything on the angles. Or diagonals bisect each other, and we don't have that. So we don't have enough information. We don't have a theorem here to say that this is a parallelogram. It looks like a parallelogram. It very well could be a parallelogram. We just don't know the lengths of the other two sides to really say. This one should be a no. All right. So 180 minus 102 is 78. So these are consecutive. 180 minus 102 is 78. So these are consecutive as well. So we know that our consecutive angles here are going to be supplementary. So this one's a yes. Officially, the theorem is if one angle is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. But I mean, we can find this one's going to be 102, right? 360. The four angles of a quadrilateral add up to 360. So if we did 360 minus the other three angles, so minus 78, minus 78, minus 102, we're going to end up with 102. So it's essentially the same thing as I'm saying with different words, right? The consecutive angles here are all supplementary. Right, so consecutive angle supplementary for this one. And we got one more of these. Okay. Is there enough information to prove that the quadrilateral is a parallelogram? So we know opposite angles are congruent, so that one would be a yes. If the opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, and then 13's the big one. Not sure how much of this I want to do. If I want to do all of it or none of it here. You know, we'll let you guys work on these ones on your own. Then you can ask during class if you have any questions. Yep, we'll let you guys work on these ones on your own.